Good day, everyone. Today, our group will be presenting Geekbench 6, a cross-platform performance benchmark developed by Primate Labs. Geekbench 6 is a proprietary benchmarking tool available on Windows, Mac OS, Linux, Android, and iOS. Its main purpose is to measure and compare the performance of CPUs and GPUs across different devices. So, what is a Geekbench 6? In simple terms, it measures how well a processor performs in real-world tasks such as photo editing, PDF rendering, file compression, and even AI or machine learning inference. Instead of focusing only on technical specifications, it gives users a performance score that makes it easier to compare different devices, even if they use different processor architectures like ARM and x86. The primary purpose of Geekbench is to evaluate single-core, multi-core, and GPU compute performance. It was developed because phones, laptops, and desktop computers have different hardware architectures, making direct comparison difficult. Geekbench solved this problem by providing one standardized scoring system that can be used across all supported platforms. This makes performance comparison much easier for engineers, students,
Now, let's look at its main features. First, it measures CPU performance through both single-core and multi-core benchmarks. And second, it performs GPU compute benchmark using technologies like OpenCL, Vulkan, Metal, or CUDA or CUDA. Third, it offers cross-platform scoring allow fair comparison between different operating system and hardware. Another useful feature is the Geekbench browser, where benchmark results can be uploaded and compared with millions of other devices. It also automatically identifies hardware information including the processor model, number of cores, cache, and memory. Lastly, Geekbench AI evaluates AI and machine learning performance using CPU, GPU, and
Applications. Geekbench is especially useful in the field of computer architecture. It helps us understand the differences between single-core and multi-core processor performance, evaluate how memory hierarchy affects system speed, analyze instruction level, parallelism, compare different processor architectures such as ARM and x86, and observe how workloads are distributed between CPUs, GPUs, and AI accelerators. Demonstrations and practical example. During the demonstration, the user simply installs Geekbench, runs the Geekbench, and waits for the result. The output includes the single core, multi-core score, and GPU compute score. For example, if the multi-core is about 4 times higher than the single core score, it indicates that the operating system and processor are efficiently distributing work across multiple cores instead of relying on only one core.
Geekbench has several advantages. It is fast, easy to use, and produces results in just a few minutes. It uses realistic workloads instead of artificial tasks, works across multiple platforms, and has a free version suitable for students and educational purposes. However, it also has limitations. It cannot analyze processor microarchitecture in detail, design digital circuits, or verify HDL code. In addition, benchmark scores may vary depending on the device's temperature and background processes during the test. To conclude, Geekbench 6 is not a processor design tool, but it is an excellent performance benchmarking tool. It helps us understand how concepts such as processor cores, cache hierarchy, and heterogeneous computing affect real-world performance. Because of its accuracy, ease of use, and cross-platform compatibility, Geekbench 6 is a valuable engineering tool for both students and professionals. Thank you, and that's